Hello everyone, good afternoon, good evening to all my dear students. Welcome back once again to Buddy Education. So students, we have almost completed a very important chapter, which is number system, right? Chapter 1, and you all know how important this chapter is for your term 1 examination. But we have only left with one part, and that part is really, you can say, the most important segment of this whole chapter, and that concept is rationalization. So today we are going to deep dive into this concept, rationalization, and we are going to do all kind of questions that may come in your upcoming half yearly examination. So I know you all are ready, you all are excited to learn how we can tackle rationalization easily. So without any further delay, let's begin with the first you can say type of question in which we have to do rationalization, right? So first let's understand that why actually we have to do rationalization, right? What are those conditions, what are those situations in which we have to do rationalization? So students, you may have seen the cases where we are having this kind of quantities, right? This kind of numbers, and the numbers are like this. For example, you have some numerator, you have some denominator, but here denominator is of some special kind. The denominator is irrational. So whenever in the numerator and in numerator to denominator form, or you can say whenever you have a p by q form and q is an irrational number, there you always have to perform rationalization. Why do we rationalize? Why do we need to rationalize? So rationalization we do to make our denominator rational. Means if the numerator is irrational, it does not matter. But if denominator is irrational, in that case we have to do rationalization. Means we have to do some process by which our denominator will become rational. Now let's find out how we actually can do it. So in this kind of process, we have two kind of question. First kind of question, the denominator will be a monomial, means only one term will be there, and in the second type of question there will be binomial in the denominator, right? So let's begin with the first example. So they are asking to rationalize 1 divided by root 7. So all you have to do is you have to check your denominator part, and whatever the number you get, right, here the number is root 7. You have to multiply your both numerator and denominator by that number. All right, so we will multiply this by root 7 and root 7. Once you will do this, students, what we will get, this will give us under root 7, and this under root 7 and under root 7 will give us 7. Now you have seen, just right after multiplying this by root 7 in both numerator and denominator, our denominator part get converted into rational format, right? And that's all you have to do. That's all why we do rationalization. I hope this purpose of rationalization is clear to all of you now, right? So ultimately what we understood that, all right, whenever we have our denominator as a rational number, we perform rationalization, and after doing rationalization we have to check whether our denominator actually converted into rational or not. If not, you can repeat this process as many as time that is required as per the question. All right, now let's move to the next question, in which we are having a binomial basically in the denominator part, right? So you can see there are two terms. Now this is not the third part, this is second part. Now what we have to do in this kind of question, right? This is the type 2 of question where we are doing rationalization. All right, So students, in this kind of question, what you will do? You will first highlight the sign which is given in those two terms, right? And the sign is positive. If this is positive, the sign that you will pick for rationalization will be negative. If this sign is negative, the sign you will choose will be negative. So if this is positive, you will pick the sign negative. If this is negative, you will pick the sign positive. So this is alternative, right? So as the sign over here is positive, so for multiplication, the number you will use will be under root 5 minus under root 2. Alright, and same thing we will use for our denominator, right? I hope this part is clear. Now suppose if in the question they have given under root 5 minus root 2, so what sign you will pick? You will pick it under root 5 plus under root 2. Alright, so after doing this simplification, what we are going to do? So when we will multiply 1 by this quantity, this is going to remain same. This is going to remain same. So we will write as it is. But now what about the denominator part? So for this, we will use one identity that we all know, right? And the identity is whenever we have this kind of two brackets, a minus b and a plus b, this thing is equal to how much? A square minus b square. Alright, now if we'll compare this thing to this, the value of a is going to be under root 5 and the value of b is going to be under root 2. Now there is one common mistake that we all can do is if you will compare this, right, and if you will take b's value as minus root 2, you may get wrong answer. So always remember when we are comparing, this is a, this is b. Alright, even here this is a, this is b. We are not considering the sign because that is already there in the bracket, right? So now if you will put these two numbers in the identity formula, what we are going to get? Under root 5 square minus under root 2 square. Now if you want to perform under root 5 square, what is this, right? Let's calculate it over here. It means under root 5 into under root 5, and once you will calculate this, you are going to get 5. So this is nothing but 5 minus 2, and then we will get the answer, the output as 3. So in the denominator part, you will get 3. So whatever you have performed here, you can write the same thing over here, right? And you can see after doing this multiplication, your output means your denominator part get converted into a rational number, and that's all the purpose of the rationalization. So I hope till this part everything is clear, right? So all you have to do, if you have only one number, you can multiply and divide by the same number, right, using the same sign. There you don't need to change the sign. But if you have two numbers in the denominator or even more than two numbers, right, then you have to change the sign but not the numbers. Means you can't flip the numbers, you can't change them, you have to use the same number but with a different sign. I hope the process of rationalization is clear to all of you now, right? But see, rationalization is that one topic from which the question is definitely going to come in your half yearly exam. Even if in future you are going to appear for any Olympiad, this is one concept that you will be utilized for sure, right? So it's a very, very important concept, and we are going to do all kind of question that rationalization may cater. All right, so let's move to the next. All right, a very, very good question. Okay, again, so the question is that root 2 plus root 3 divided by 3 root 2 minus 2 root 3 is equal to a minus b root 6, and you can see as a and b are unknown here, so they want us to find the value of a and b. All right, so the first thing that strikes our mind over here is that yes, the denominator part is having some problem, right? And that problem is that it is irrational, and and we don't want the denominator ever to be irrational. So which process will help us in changing this to rational? It will be rationalization, right? So the first step is clear. All right, it means in the LHS part we have to first rationalize this, right? So for this, first I am going to write my denominator part as it is, right? After this, as this is 3 root 2 minus 2 root 3, we can clearly see that this sign in between is negative. So by which number we have to multiply? 3 root 2 plus 2 root 3, and the denominator part will be 3 root 2 plus 2 root 3. Now first part is clear, right? First part is clear. After this, all we have to do is just the simple modification and calculation by using few identity. So let's first multiply the numerator part. So for the numerator part, we know how to simplify two brackets at a time, right? So for this, first root 2 will be multiplied with 3 root 2 plus 2 root 3. All right, and then we will multiply the same bracket, which is 3 root 2 plus 2 root 3 with this. All right, and after this, what we will do, we will use the same identity that we have used in the previous part, and this is the only identity that will be usually used in this kind of question, right? So the identity is a minus b and a plus b, right? So if you will do this, this will be a square and minus b square. All right, all right. Now let's calculate it. All right, okay, let's change the color. So when root 2 will be multiplied with 3 root 2, it will become 3 into 2, right? When root 2 will be multiplied with this will become 2 root 6, and when these two things will be multiplied, plus will be remain same and 3 root 6, and then when you will multiply these two things, so it will be 2 into 6. All right, now the first numerator portion is clear. Now we will divide it. Now there is also one common mistake that we do in the denominator part when we have two numbers to be squared, right? So usually what student do, they do it 3 into root 2 ka square. We know that it's 2, so they will write 6 over here. But when you are doing 3 root 2 whole square, right? When you are doing 3 root 2 whole square means 3 root 2 into 3 root 2. So these number will also be squared, no? So 3 3s is 9, and then it will be 2. So this will be 18, right? This is very common mistake when for doing 3 root 2 square. Many students write it as 3 into 2 as 6, right? And this is absolutely wrong. All right, so just be extra cautious when you are simplifying this kind of term. So when you will do this, this is 3 3s are 9 into 2 18, and then this will be 2 2s are 4. 4 into 3 12. All right, now let's erase this part and solve over here, right? We are just about to get our solution in a while. All right, now we have to calculate all this part. So this is 3 2s are 6. Okay, then 2 root 6 plus 3 root 6, 2 and 3 5, so 5 root 6 we will be having, and this is 2 6 are 12, so over here it will be 12, and this thing will be divided by 18 minus 12, that is equal to 6. Now you can further add them, so you have to keep on simplifying till the time it can be, right? So 12 and 6 again 18 plus 5 root 6 and divided by 6. Now if you want, you can categorize this, right? You can also write it as 18 by 6 plus 5 root 6 divided by 6. Now for some simplifying it further, you can also do it like 6 3s are, so this is 3 upon 1 plus 5 root 6 divided by 6. Now don't do this mistake that you will cut down root 6 by 6, because again then you will have your denominator as irrational number, right? So don't do it. Now what after this, right? So after this, they have given in the question that this whole thing, when it will be simplified, this whole thing is equal to a minus b root 6. So the last step is to compare LHS and RHS, right? Now look at the LHS. There is a rational part, there is a irrational part. Then same in the RHS part, there is a rational part and there is a irrational part, right? So after this, all you have to do is just to do the simple you can say comparison. So when you will compare, the rational part over here is 3 and the rational part on RHS side is A. So the value of A is equal to 3. And when you will compare the remaining part, so over here the irrational part is 5 root 6 divided by 6 and the irrational part over here is minus B root 6. So don't forget the sign, because this is also a common error that we do, right? So this root 6 will be cancelled. So the value of B that you will get is minus 5 by 6, and that's all they wanted you to find. All right, so I hope this question is clear. See, there is no complexity in the question apart from this calculation portion. And trust me student, if you are not skipping any smaller part, then there is no issue with this kind of question. And this is those kind of question that you always see in your examination, right? No matter it will be a class test, no matter it will be your half yearly exam or even final examination, this is a very, very, very important kind of question, right? Let's just quickly revise it. So in the question, they have given us 2 unknown variables for which we have to find the value, and we have seen that the denominator part is irrational. That's why we started rationalizing. So we have seen that this is negative over here. That's why we have chosen the sign of positive plus over here, and then we multiplied it, right? Then we know how to multiply 2 brackets, then we have written them down and we have expanded it, right? Then we have done all the calculation, and after calculation we have reached this step. Now this step is clearly equal to this part, and then we have compared the rational part to rational and the irrational part to irrational, and that's how you can solve any kind of question which is similar to this pattern, right? Okay, so I hope till this part everything is sorted, everything is clear. Now let's move to the next question, and the question is, all right, again a very good question. Okay, so the question is that I guess there was one more question left. Yes, this is also very, very good kind of question. They're saying simplify this. Now if you see this question, then there is nothing written inside this square root on which we can use any identity, any formula or anything like that. Even rationalization is also not required. Then how to do this kind of question? Now for doing this kind of question, just keep one thing in mind, that there is only one power, there is only one superpower that can eliminate square root, right? And that power is always try to make a whole square, because if you will make a whole square inside a square root and that whole square will be cancelled out. So all you have to do some manipulation inside this, that it will be converted into whole square. Now how we'll do it, right? Just see that for this 3 plus 2 root 2, can you also write this 3 as 2 plus 1? Definitely we can do it, right? And if I want further, then just think about a number which is the square of 2, and that number is for sure under root 2. So in place of 2, we have just replaced under root 2 and square. Now 1 is definitely the square of 1, so we will replace this by 1 square. And then what about this thing, right? So can you also write it as 2 into 1 into root 2, because when you will calculate it, you will again going to get 2 root 2, right? Now, why we have specifically done this thing, done this manipulation, right? Because we know that there is one identity like this, a square plus b square plus 2ab, right? And this is the identity of a plus b whole square, right? Now you try to compare this, right, with this is a square b square 2 into a into b, right? So we get to know that instead of this whole thing we can also write root 2 plus 1 whole square, and now you know that this whole square will be cut down by square root, and then you will left with under root 2 plus 1, and this is all that you need to simplify this particular kind of question. So whenever you have this kind of question, try just to break it, right, in such a way that it will become a perfect square, right? So very, very important and unique kind of question. I hope till this part nothing, there is no doubt, right? And if you are finding any doubt, you can comment me down so that I can repeat that thing. I can even make a separate video if you stuck in any kind of question. All right, now let's move to the next question, and the question is this. Okay, question is that if x is equal to 2 plus root 3, then we have to find the value of x cube plus 1 upon x cube. Okay, now whenever you have this kind of question, first you can see that we have the value of x, but we don't have the value of 1 upon x. So first hint is clear that you have to find the value of 1 by x. Okay, so we'll write that x is 2 plus root 3, then 1 divided by x will be equal to 1 divided by 2 plus root 3. Now, are you okay with this thing? So the answer is no, ma'am. Why? Because ma'am, you have told us that we can never keep irrational number, we can never keep an irrational number in the denominator. Means the first thing that we got as a hint that you first do the rationalization. So over here, you will start rationalizing it. So we'll use this sign for sure, 2 minus root 3. Alright, so once you will do it, it will be 2 minus root 3, and again in the denominator part, can't we use the identity? For sure we can use the identity. So it will be a plus b and a minus b, so a square and minus b square. Alright, now let's calculate this further. So you will be getting 2 minus root 3 and divided by, now 2 square is 4 and root 3 square is 3. So you are going to get the value of 1 upon x as 2 minus root 3. Now what after this, right? So now again see, whatever simplification was required for this we have done, but you know that for this we have to use some identity, or you can say some formula. So we do have a formula in which we have a cube parts, right? So the formula is like this, that a plus b whole cube is equal to how much? A cube plus b cube, right? And plus 3ab into a plus b. You all know this identity that we already have studied in the previous classes. All right, now the thing that you are finding is this, right? Because in place of a, what we are going to keep? X, and in place of b, what we are going to keep? 1 by x, right? So when you will do this, can you do some manipulation like this? A plus b whole cube we are keeping on this side, and we are bringing this whole thing on the other side, so it will be like this, and this will be now equal to a cube plus b cube, right? And in this identity you have to plug in the value of a and b. Now you can see the value of a is going to be how much? X, and the value of b is going to be 1 divided by x. So now let's perform this on the next page. So when you will replace a by x and when you will replace b by 1 by x, okay, what you are going to get? So this will be x cube plus 1 upon x cube, and this is going to be how much? A plus b whole cube. So a plus b whole cube minus 3 into a into b. All right, and then it was a plus b. This was the identity that we have written earlier. Now let's solve this. Let's watch out what was the value of x. So the value of x was 2 plus root 3 and the value of 1 by x was 2 minus root 3. So we are going to put all these values over here. So the value of x was 2 plus root 3 and the value of 1 by x was 2 minus root 3. Now it is very simple to calculate this. This x will be cut down, so this will be 3 only, and this will be 2 plus root 3 plus 2 minus root 3. All right. Now after this, calculation is very simple. This will be cut down and then you will be left with 2 plus 2, 4 cube minus 3 into 2 plus 2, 4. So this will be how much? 64 minus 12. So your answer will be 2 and 1. 52 is the answer, is the value of x cube plus 1 by x cube. And this was the thing that they were asking us to find in that question. So I hope this question is clear, but it is, again I'm saying that all questions that we are doing in the class are unique and they are all those kind of questions in which most of us stuck. So make sure even if you are not able to understand them in one go, kids, I am requesting you to watch the video again. Okay, you can also use a slower speed. Okay, and then try to watch the video of one question, try to do it, and then try to do similar kind of question that I am going to provide you in the form of worksheet, and I am going to upload it on the Telegram channel. So make sure, if you have not joined the Telegram channel yet, go and join. All right, chalo. All right. So our next question is this. All right, the question is that they have given the value of x as 3 plus 2 root 2, and then they are asking us to find the value of under root x minus 1 upon under root x, right? Somewhat this question is similar to the previous one, but the only difference is in the previous question it was very evident that we can use the identity which can contain cubes, but do you have any identity that will have square root? So the answer is no, ma'am. We haven't studied any identity so far which is having under roots in them. But now how we'll do it? Now you know that under root square root can be handled only by one thing, right? And that superpower is the square, right? So instead that we will think the identity that will contain square root, we'll think about an identity that is having square, right? And we know that there is one identity in which we have a square root part, right? This is not negative, this is positive in the question. So just change this part. Okay. Now how we can do it? That first, if x is equal to 3 plus 2 root 2, try to figure out the value of 1 upon x, right? So for the value of 1 upon x, we will write this. Now as soon as you will write it, you will find that, ma'am, we have to now rationalize this, and for rationalization we will use 3 minus 2 root 2 and 3 minus 2 root 2. All right, so let's just write it again. 3 minus 2 root 2. Okay, then can we simplify this? Yes, numerator part is very simple here. The numerator part is very simple, so we have written this way. Now what about the denominator? So I told you, kids, that denominator part will be mostly solved by using the identity a plus b and a minus b. So once you will use that identity, it will be a square minus b square. All right, now let's solve this further. So this will be 3 minus 2 root 2. Now what's the square of 3? The square of 3 is 9. What's the square of 2 root 2? So 2 square is 4 and into 2. 4 into 2, 8. So the value of 1 by x is going to be how much? 3 minus 2 root 2 divided by 1. So but 1 we don't need to write. Now what after this? We told you that there is no identity that is having square root, but we do have an identity that have a whole square, correct? So the identity of a plus b whole square is a square plus b square and plus 2ab, correct? Now if you will just replace your a by x and you will replace your b by root x. Okay, 1 upon root x, right? This is 1 upon root x. Okay, what you are going to get over here, it will be root x. Okay, then it will be plus 1 upon root x whole square, correct? And this thing will be how much? This thing will be a square means root x square, which will be x, and this will be 1 by x, and then this thing will be under root x into 1 upon under root x, right? We have just replaced it by root x and 1 upon root x. Now after this there is a simple calculation. This will be cut down. All right, now the value of x is 3 plus 2 root 2. So we will just write the value of 3x and the value of 1 by x is 3 minus 2 root 2, and then the last thing is 2. Okay, let's see what all things can be calculated. So this will be cut down. So 3 and 3, 6 and plus 2 is 8, right? 3 and 3 is 6 and 2 is 8. Now what you have to do, the last step, because we are having square here and they were only asking for 1 power, right? They were only asking for power 1. So we will take that square to another side. So the final answer of this question will be root x plus 1 by root x will be equal to under root 8, and this is the final answer for this question. Now even in the case if they have given minus over here, you can use the identity of a minus b whole square, and you can use the same process, but in that case this will be negative. So 3 plus 3 is 6 minus 2 how much it will be? 4. So 6 minus 2 will be 4, and then it will be square root of 4. So in that case the answer would be 2, right? So it can be anything. It can be even plus, it can be minus. So you can, now if I have done for plus, it is your responsibility that try to do it for the negative sign, right? So even if we haven't changed the sign, you can do this question. There is no problems. But I hope the process is clear that why in the case of under root x we have used the squared identity, but because you know that there is no identity on square root, but there is an identity on squares, right? Now this is also one kind of question, those questions which you may see in your upcoming examination, and the question is like that we have to find the value of this given the value of under root 3 and under root 5 is this. All right, now you all know that at instance if you have put the value of root 5 over here, suppose I have put the value of 2.236 and that they are saying us to add the value of root 3 which is 1.732. so first you will add it, but then you will get a very difficult or you can say complex calculation portion, right? If you will put this in the starting, in the beginning, right, you can get the answer, but the calculation part will be very lengthy. So now what to do, right? What is that one procedure that can help us, right, in simplifying the calculation part? So you will all know that whenever we see any irrational number in the denominator part, the only thing that can help us is rationalization. So first, instead of putting the values directly, we will do rationalization, right? So we'll write this number So this thing we will not do. Okay, root 5 plus root 3, and we will multiply this by root 5 minus root 3 and root 5 minus root 3. All right, now let's do it. So this will be, now we don't need to, you know, simplify the numerator part first, because there can be quantities that may come in the denominator from which the numerator's few portion can be cut down. All right, so when you will use the identity a plus b into a minus b, this will be a square means 5, b square means 3. So over here you are going to get 6 minus root 5 root 3. This is under the bracket, and 5 minus 2 3. When you will cut down this, so the final thing, final simplified part that you are going to get is this. And now this part is ready to consume the value of root 5 and root 3 in the decimal format. So let's put it now. So this is 3, root 5's value is 2.236, 2.236 and minus 1.732. All right, now let's calculate this first. 6 2 is 4, 3 3 0, 12 and this 5 and 0. All right, let's multiply it further. 3 4s are 12 and 15. All right, so this is the final answer for this question. And you have seen that even if the decimal parts were very long, the calculation is very simple. But if you will do this, then calculation is automatically going to be very, very complex. So students, it is now very clear that if the denominator is irrational, right, doing rationalization is must. I hope this whole question is clear, and now somewhere we are going to be very confident about any kind of question that may come from the concept rationalization, because I am trying my best that we will cover up all kind of questions of rationalization. All right, now let's check the time of your class, so that all right, we still got a lot of time. All right, so now here the question is that you have to prove, right, you have to prove that this whole thing is equal to 0. Now you can see that this question is nothing, but we have 3 different parts, and all 3 parts just require one thing, that is rationalization. So let's do it for each part, and then let's see whether this thing is equal to 0 or not. All right, so this will be 3 root 2. The first portion I am writing 3 plus root 6. So I am going to rationalize this. So once you will rationalize this will be 3 minus root 6 divided by 3 minus root 6. Now for the second part, we'll use the same process, and we will write our denominator like this, and we are going to multiply it by 2 root 3 minus root 6 divided by 2 root 3 minus root 6. And then the last part is 4 root 3 and divided by root 2 plus root 6. So its rationalization factor will be root 2 minus root 6 and divided by root 2 minus root 6. So I hope till this part everything is sorted, because there are only 3 different sections for which we have done rationalization. Now let's be little cautious when you are doing multiplication. Okay, so here it's in bracket, it's in bracket, it's in bracket. Okay, so when these 2 things will be multiplied, 3 3s will be 9, root 2, then there will be negative 3, and this will be 12. All right, in the denominator we have to use the same identity, a plus b into a minus b. So when you will multiply it, this will be 3 square and minus root 6 whole square. All right, now let's move to this part. 6 2 is 12, root 3 minus 6 root 6, and this will be divided by how much? This will be divided by 2 root 3 whole square minus root 6 whole square. And then we are at the same at the last part. So this will be 4 root 6 minus 4 into how much? 3 6 are 18. All right, and then this will be divided by under root 2 square minus root 6 square. Now let's calculate it further. So this will be 9 root 2. All right, what about this? Right, you can split 12 as 4 into 3. Right, we can split root 12 as 4 into 3, and 4 is the square root of 2. Right, so 2 will come out, so this will be 6, and then we will be left with root 3 inside. So we have, what we have done, root 12 we have splitted as 4 into 3, and then we have written as 2 root 3, and then the 2 will be multiplied with 3, so 2 3s are 6 and root 3. Right, this will be 3 3s are 9 minus 6, this part will be 12 root 3. This is all right, this is also all right, and then 2 2s are 4 into 3, so this will be 12 minus 6 and minus 4 root 6 minus 4. Now what about 18? 18 is prime? No. So again we will break this as we have done with 12. So 18 we can write as 9 into 2, and 9 when we will keep out, it will become 3. Right, so this will become 3, and then 3 into 4 is 12, so 12, and this we have broken as 9 into 2. Right, so under root 2 and 2 minus 6. Right, now what you have to do, kids, you have to just now simplify this. Okay, then this will become 9 root 2 minus 6 root 3 divided by 3. This will be 12 root 3 minus 6 root 6 divided by how much? 6. This will be 4 root 6 minus 12 root 2 divided by how much? Minus 4, and then minus minus will be plus 4. And then when you will take the LCM, for sure you are going to get 0. Now this is one little portion that I am going to hand over to you for your as little homework. So I guess after this, the complex part I have already done, where you may do mistake, but after this it is just a very small calculation, and I am very sure that all of you can do it. So if not, right, you can comment me down that yes ma'am, we were not able to do it, so we can repeat this. All right, but for now let's move to the next one. And next concept is laws of exponent and power, and this is the only remaining segment of this whole chapter, else we are done completely with number system. And I have tried to make sure that all the important kind of question will be covered in your class. All right, so there are few rules that you have already know, but so we are just quickly revising them. Right, so the first rule that you all know is, if we do have two number where the bases are same, where the base is same, okay, then the powers will be added. This is the first rule. Then the second rule is that if you do have the same thing, means you have same base, but those numbers are in division, then the powers will be subtracted in this manner. All right, then you have a rule like this. If you have a number like a raised to the power m, and then you have a further power n to that, then you can write it as a raised to the power m into n, right, where a is any real number. Okay, then you have one more rule, that you have a raised to the power m and then b raised to the power m. Now what's the difference in the first one and this? Here the base were same, power is different. Here the power is same but the base is different, so you can write this number as a into b whole raised to the power m. Now we many times get confused in these two rules, so always be very cautious, right? And then you have the same law with division, that if you have a number a raised to the power m, you have a number b raised to the power m, then a upon b can be write down, this thing can be formed in this way. All right, then there is a rule that if you have a raised to the power minus m, then you can write it as a 1 upon a raised to the power m, right? This is very, very important rule. So these are few rules of exponent that will help us in finding few problems, right, of related to some exponents and power. All right, so now without any further delay, let's move to the first question, where they are saying that let's find the value of this. Okay, so for finding the value of 64 raised to the power 1 by 2, we have to make sure one thing only, that inside, apart from the power, the base should be prime, but 64 is prime, so the answer is no. So try to make it prime. So when you will calculate this, right, when you calculate this, means when you will prime factorize it, you will be getting 2 into 2 into 2 into 2 and into 2, right, and this power raised to the 1 by 2. all right, this is 2 raised to the power, how much we have only written, no, there will be one more 2, so let's rewrite this. all right, this is 2 raised to the power, how much, 6, 3 and 3. So can you now further write it as, because 1 1 1 1 1 1, right, as per the first rule. So whatever rule you are using, make sure that you are, what you are doing, sorry, base is same na, this is not the rule, this is different one. So when you have same base but different power, the powers will be added. So the bases are same, power is 1 1 1, how many powers in total, 6, and this whole thing is raised to the power 1 by 2. Now according to this rule, when you have a raised to the power m raised to the power n, then you multiply both these power, right. So accordingly this will be 6 and 1 by 2. When you will cut down, you are going to get 2 raised to the power 3, and 2 raised to the power 3 is nothing but equal to 8. So the answer of this question is equal to 8. Now let's move to the next part. Okay, there are 3 parts of this question. Let's do this part. Okay, let's do this part. Again you have to ask the question whether the base is prime or not. So the answer is the base is not prime, so let's try to make it prime. So when you will find out the prime factors of this, you are going to get 5 into 5 into 5 raised to the power 1 by 3. all right, and then you can write it as 5 raised to the power 3 whole raised to the power 1 by 3. all right, and then whatever rule you are using, make sure while doing any kind of question of exponent and power, you mention the rule. So here we have also used this rule. So once you will do it, this will be cut down, so we will left with 5 raised to the power 1, and that's it. That's all you have to do in this kind of question. So the only rule that we have understood so far, that if the base is not prime, try to make it prime. Now this kind of question we have already completed in our grade 8. So I just want you make practice the question, right, that may help you to you can say explore the new dimensions of exponent and power, right, where some tricks are used, where we have to really give a deep thought that what rule specifically we will use in each and every step. So this part I will do for you, that is one for your homework. Okay, so here again the question is that base is not prime, so let's change it. So when you will convert 32 in prime factor, this will be 2 into 2 into 2 and how many, 4, okay, into 2 raised to the power 2 by 5. okay, now the bases are same, so the powers will be added. So this will be 2 raised to the power 5 raised to the power 2 by 5. Now you can see that these two powers can be multiplied. So 5 into 2 by 5, once you will calculate them, students, what you going to get, 2 raised to the power 2, which is equal to 4, right, and that's all you have to do in this kind of question. Always try to manipulate your base part into prime factors. Okay, all right, now let's move to the question that I really want you to understand. The question is that we have to prove that this whole thing is equal to 1. okay, so what we will do in this question, we'll take one part and we'll understand that which a law of exponent can be used here. So one thing is very clear, that whenever we have a negative part, right, this is x raised to the power b, and then we can also write it after segregating in this manner. We can write it as x to the power b into x raised to the power minus a, and then the same thing we can do with x raised to the power c and then x raised to the power minus of a. This is for the first portion. So we have done this part. Same thing we will do with the next part. So we will keep on writing after segregation, and we are segregating the negative parts in that from that. So this will be x raised to the power c into x raised to the power minus b, and then we are having 1 plus x raised to the power b into x raised to the power minus c and plus x raised to the power a into x raised to the power minus c, right? So whatever you have done with the first part, you are just following the same thing with the second and third. Now what after this, right? After this, you know that there is a rule that if you have a raised to the power minus m, you can convert it like this. So we'll do the same thing with this and same in the last part. So let's try to do it. So this will write x raised to the power b divided by x raised to the power a, x raised to the power c divided by x raised to the power a. We are following the same process for the second and third. So you are going to have x raised to the power a divided by x raised to the power b plus x raised to the power c divided by this, and same procedure for the third part. So I'm just quickly writing this. Okay, and then this. Now what after this? What after this? You know that there is a fractional part, so we will take LCM over here. So when you will take LCM, the LCM will be x raised to the power a, right? So over here this will, you will get x raised to the power here, this will be x raised to the power b, and this will be x raised to the power c. And see, slowly and slowly you are seeing that there is, you know, few common terms started appearing. Over here this will be 1 whole divided by, this will be x raised to the power b is the LCM portion, so this will be x raised to the power b, x raised to the power a plus x raised to the power c. And same thing we are doing for the last part. X raised to the power c is the LCM, and this will be x raised to the power c, x raised to the power b and x raised to the power a. Now you can see that this thing will be go to upward side. So for the first part, this will be x raised to the power a plus b plus c. For the second part, x raised to the power b is going upside, so this will be b plus x raised to the power a plus x raised to the power c. And same for the last part, this is c and x raised to the power b and x raised to the power a. You can see that the denominator part is same apart from its order. See, either you write 1 plus 2 plus 3 or you write 3 plus 2 plus 1, they all are the same thing, means this thing and this thing, everything is same, right? So again, just take the LCM. LCM will be x raised to the power a, x raised to the power b and c. So from here, this will be x raised to the power a. From the second part, this will be this and this, and you can see again they are same, so this whole thing will be equal to 1, and that's all you have to prove in this question. But this question is very interesting, and you can never be sure in this question if you will not practice it by your own, right? Though only one rule of exponent is used, but the calculation is little confusing. So make sure कि after this class, when you will take a break and after some time you will practice it by your own. All right, so now let's move to the next question. And again, the question is very interesting and very important question, okay, let's do it now. Question is, if a into b into c equal to 1, then we have to show that this whole thing is equal to 1. All right, so for this you can see that there are few negative parts. So we know that we have written one rule that a raised to the power minus m is equal to 1 upon a raised to the power m. We'll perform that thing. So this will be a plus 1 upon b, this will be 1 upon 1 plus b plus 1 upon c, and the last part will be 1 plus c plus 1 upon a. All right. Now what after this? Okay. Now this is not that one question in which whatever you will do for the first part will be continued for second and third. That's why it's a tricky one. All right. Sorry. So here first try to take LCM. Okay. When you will take LCM over here, B will be the LCM, so this will be B plus AB plus 1, okay, and remaining part I am writing same for now, okay. Suppose this is same. Now after this B will go up, and this what you will remain with, you will be left with AB plus 1, and then here this is 1 plus B plus 1 upon C, and then in the last part this is 1 plus C plus 1 upon A. Now why I have told you that this is not that one question in which the first thing will be followed with the second and third. See here, if you will take C as LCM, right, then what it will become, C plus BC plus 1, and C will go in the numerator part later on. So you can see, just like the previous one, you have done the same thing because the denominator part was same, but here if you will do the same thing, you are not going to get the denominator same. So instead what you have to try, you have to figure out that what is the denominator of the first one, and you have to try to make sure that the second and third will follow the first pattern. So here it is B, here it is B, here is 1 we do have, but what is the but the problem is with C. So in place of C there should be A coming, there should be terms with A coming. So for that this thing we will utilize from here. Since A into B into C is equal to 1, can you write 1 upon C as AB? For sure we can, right? So in place of 1 upon C over here, over this part, I will replace this with AB. So first part I am writing same. So first part is B plus AB plus 1, and in place of 1 upon C I am just writing AB, and then you can see this part and this part automatically become same. Now what about the third part? Now if you will see the third and the first part, B is there, so the answer is no. 1 is there, answer is yes. A is there, yes. So the problem is with B. So what you have to replace is, you can't replace 1 upon A, you have to replace the C portion, because A we need. So now again from here, can you write C as 1 upon AB? Yes, we can write. So over here you will replace your C as 1 upon AB, and you will keep your 1 upon A same. Now this is the only point you have to understand, that what is the manipulation you have to do with the first, what is the manipulation you will follow for the third one, and the hint you will get from the first portion, right? You see that what if we need A, we will not remove it, we will not do any manipulation with A. If you need B, then you will not touch the B part, okay? So this we will write as it is. Okay, here we are writing this as it is, and this we are again writing as it is, and the third part, right? We can take LCM over here, and the LCM will be AB. So this will be AB. This is already having AB, so this will be 1. A is there, so B will come. All right. Now let's write it again. B plus AB plus 1 divided by 1 plus B plus AB, and then this AB will go up, and this will, now you can see the denominator part is same apart from its order, right? So B plus AB plus 1. So this will be B from here, 1 from here, and AB from here, and you can again see that numerator and denominator becomes same. So the final answer is 1. But it's a very, very good question. Make sure students that you will note it down, and you will at least practice this twice. All right. Now I don't think we are left with any question. I have tried to make sure that we will cover up all kind of different questions, but still if you may find any question which you are not able to understand, you can always send that question to me in the comment box, right? I hope now we all are sorted with the first chapter, number system, because after this in your upcoming class we are going to take up the chapter polynomial. Again, a very important chapter. It's that one chapter which is not only important for your grade 9, but even this is very important for your grade 10th, 11th and even so on, right? So I hope that now we all are sorted with the chapter number 1, and I'll see you all in my next class with a new chapter, polynomial. Till then, bye bye, take care everybody, good night.